Our next presenter is Dr. Doug Tocher, who really needs no introduction with over 300 publications in the area, who's going to be talking about camelina and Atlantic salmon, or I assume Atlantic salmon.
Okay, thank you. Yeah, where's the buttons? Yeah. Okay, yeah. So I'm going to talk about the development of camelina-based alternative to fish oil that can supply EPA and DHA, primarily for salmon farming is really what our target species, but of course it can be for any aquaculture. And I have to say that I'm really here as a proxy because all of the cool science in this was actually done in a 20-year period that I've been collaborating with Professor Jonathan Napier and his team of crop scientists and molecular biologists, Rothamsted Research, Crop Research Institute in the UK, government funded. And so 20 years of work, I'll sum it up in 10 minutes. Okay, so to sum it up, I'll get rid of that because we don't really need to look at that. So, producing fish oil in GM plants, it's a very simple concept that you marry the trait of oilseed crops to deposit and accumulate large amounts of lipid in their seeds with the traits of microalgae to produce the fatty acids that we're actually interested in, which is EPA and DHA. So we've got the top pathway there in green, which is what land plants, the pathway of PUFA biosynthesis in land plants is, terrestrial plants. And then down the vertical line here, we've got the genes that we have, that Jonathan has isolated or used from marine microalgae to produce EPA and DHA in these transgenic oil seed crops. I mean, it's a very simple process. So, you know, hey presto, you've got EPA and DHA. It just took 15 years or so of very hard work by these dedicated people at Rothamsted. So why did we choose Camelina sativa? Well, they've got seeds with quite a high lipid content, 40%, pretty close to canola or rapeseed oil as we call it in Europe, naturally rich in 18,3-3. They have other agronomic qualities that they can probably grow in marginal land and it can resist drought and disease. But one of the most important things is that we've got this huge vegetable oil industry out there, that 200 million tons of vegetable oil is produced a year. All we had to do was convert some of that crop to produce the fatty acids that we need. So we don't really need to use more land. We don't need to use more water. We just need to use, maybe convert 1%, 2% of that entire world production of vegetable oil to producing something like this. Okay, so, and sorry, I should say that my aim in all of this is based on salmon because that's our target fish species. And in Scotland, we've done the work over the first 15 years of this collaboration. I was doing what everyone else was doing, and that was vegetable oil substitution of fish oil and trying to mitigate the negative impacts on omega-3 content in salmon. And of course, we were very successful because we reduced the level of marine ingredients in the feed in salmon by fourfold, from about 80 to 90% down to 20-25%. But the level of EPA and DHA only decreased by half. So we think that's a pretty successful thing, but we think it's gone as far as it can go. At the moment, you know, back in 2006, one portion of farmed salmon would have given you your weekly, daily required intake of EPA and DHA. Now you would need to take 2 portions of salmon. It's not that salmon's a bad product or anything. Now it's still a great product, a great delivery system for EPA and DHA, but it could be better if we could restore it to where it was. And that's really what our aim was. That was the challenge that I set out to Jonathan and his team. Produce an oil in GM Camelina that had about 25% EPA and DHA. And we've been using an iterative process. So the first thing we did was produce an EPA version of the oil by just putting in the genes to produce EPA. Then we add a few more genes to get DHA. And so 2 main oils that we've done is and here on this graph in the blue is what the fatty acid composition of a fish oil is. That's a regular fish oil. And then in the green, we've got the 2 iterations of GM Camelina. In the light green, it's the high EPA one. That has about 20% EPA, a little bit of whiff of DPA, no DHA. And then the other oil, as you can see there, the EPA DHA oil, the dark green, we've got about 11% EPA, about 9% DHA, and about 6 or 7% DPA. So that has hit the target of 25% of long-chain omega-3. However, It's not actually a fish oil, it's a hybrid oil because we've also got high levels of 18.2N-6 and 18.3N-3, and I'll talk about that if anyone asks a question. But I'm not that worried about the 18.2N-6 because our diet's awash with it anyway. Eating a piece of salmon that has some 18.2N-6 will do almost nothing to your 18.2N-6 content of your diet. So we shouldn't worry too much about it. Okay, what have we done? I'm not going to go into great details of results because it's all in the public domain. It's all been published. We've done, actually, we're in our 6th trial with salmon. We've also done a trial on sea bream and sea bass. And we've used both the EPA-only oil, which is a great research tool, actually. I was very keen on getting that oil. But the main product is the EPA plus DHA oil. So we've done about 7 or 8 trials in fish. There's also been a trial in salmon, in mice, done in the University of East Anglia. And there's also a project going on in direct human consumption of these at Southampton and Reading universities in collaboration with Rothamsted. So I'm not going to go into great details, simply to say that these oils have supported good growth in the fish. There's not been any negative effects that we've noticed on survival or production parameters or fish health. And of course, we have increased the level of omega-3 in the flesh compared to fish being fed the sort of standard commercial diets with high amount of replacement of fish oil by regular vegetable oil. This has culminated in our last trial, which was published in June last year at the same time as the ISFN meeting in Las Palmas. In this trial, we compared a commercial salmon formulation, 5% fish oil, 15% rapeseed oil, and a low level of fish meal, around about pretty much reflecting the Norwegian standard diet in about 2016-17. And we compared it with the DCO EPA DHA oil that has 25% EPA, DHA, and DPA. And what you can see there is comparing the blue and the green. The blue is the fish fed the current commercial standard diet, and the green is what we were feeding them with the GM camelina. And as you can see there, I've put that we were replacing both fish oil and vegetable oil. We don't just go about replacing the fish oil. We see this as a vegetable oil substitute as well. And so we were able to restore levels in the salmon fillet to what they were about 15 years ago, before all of the major substitution. As I say, then the difference with this talk to many of the talks, or certainly like yesterday, is the fact that this is all in the public domain. It's all publicly funded. Every single piece of work we've done has been funded by research councils in the UK, Norway, and the European Union. 7 or 8 papers published. We've been around numerous international conferences and just presented all our data. And we've also done a lot of public dissemination. And there's just some of the other publications. Just to give you the current update, we're running a trial now on the west coast of Scotland, growing fish from 200 grams up to 4 kilos, around about market size. That required us to produce about a ton of this oil, which was actually grown here in North America, because obviously there's issues with GM in Europe, unfortunately. And so this is actually going to be harvested next month. We're actually using a Chilean formulation, because if these GM oils are ever going to be used in salmon, it's not going to be in Norway or the UK. Or in my lifetime, I would probably say, but it might be able to be applied in Chile. And the most important thing about this trial is, as well as doing it in near commercial or close to commercial conditions, and we can get the proper production data, we can also get the data on product quality that we can't get with a smaller fish, and also consumer acceptance. We'll be doing consumer tests on it as well. I'm going to whiz through these slides. Obviously, there's huge barriers in terms of regulatory issues, which I won't talk much about, in public perception, which I will mention. So we had a news story. When we were running this trial, starting near the beginning of it, we had a big splash in the BBC News at lunchtime. And by tea time, there was 266 comments to this news item. And I got then Monica Betancourt to do a wee bit of analysis on that. And when you get rid of all the multiple postings by anti-GM people, because these are very dedicated people that have got nothing better to do than tweet and post all the time, we had about 110 unique responses, 80% negative. If you break it down to what they were negative about, it was, of course, in particular GM and aquaculture, but aquaculture got more of a pasting than GM did. This is what we have to deal with in Europe and the UK. How do you deal with that? I don't know. The Research Council in the UK is very keen on us to use this as a sort of pathfinder project to engage the public in a meaningful debate on the GM. I think it's impossible. It's, you know. These people that are anti-GM are very tough nuts to crack, with the emphasis on the nuts. So anyway, as you can see, we've been around science festivals, but these are not the people that we're trying to convert because they're already open to science and to technology. An interesting thing in terms of the regulatory issues, let's face it, in Europe this is going to be a very difficult problem to solve. Probably never get regulatory approval and in Scotland we've got an anti-GM government. When that story came out, one of the people that got attracted to it was a Scottish minister in the government who brought down the weight of all the Scottish agencies on me to check I had all the correct licenses, etc. for running a GM trial in Scotland. That was a fun month. Okay, so my questions, my last slide. As you can see, I have slightly different view to maybe most of the people in this audience. I don't see these things really as simply fish oil replacements. I see them as vegetable oil replacements. Fish oil is not causing a problem in any of our feeds. It's vegetable oil that causes a problem because it reduces the nutritional quality. So what is our aim here? You know, is it just to maintain current EPA and DHA levels in flesh? It's not very ambitious. Is it to mirror wild fish? I think a lot of the public would think that that's what we should at least have, similar to wild fish, or restore those levels to what they were before we did all the substitution. Thank you.